Okay, everybody, I want to just work out number 8 on that colligative property homework. I was doing it halfway during the Zoom session today, but the amount of variables that are involved in that problem is just a little confusing, so I didn't want to make any miscalculation there. So I told Tristan, who was asking that question, that I'm going to do it here separately. Just to rephrase the problem a little bit, same idea that I presented during the Zoom session. Basically, you started with some benzene and toluene that are in the liquid state, right? So that's in container 1 here. So that's the stuff at the bottom. And then the benzene and the toluene liquids, because they're volatile, will generate a certain amount of vapor pressure, which then makes up the benzene gas and toluene gas in container number 1. Okay? Now, what you do then is you take that benzene and toluene in container number 1 that's in the gas phase, you condense all of them. Okay, so basically imagine you take all that gas and you cool it down so that now they're all liquid. And that makes up the liquid benzene and toluene in container number 2. And you let that liquid equilibrate with its vapor. So you kind of basically let some of the benzene, some of the toluene evaporate because, again, they're volatile. So now they make the benzene gas and toluene gas in container number 2. And what they say is that in the question, they say they take that and they condense it again into liquid for container number 3. Although it's not really critical, that's third part of it. I know in the Zoom session, I had spent some time explaining how that liquid in the 3 is coming from the gas in number 2. But really, in solving the question, it's not that critical, because what they were telling us is, in the question, they were telling us that the mole fraction of the gas of benzene in container number 2, which is, you can write it as that, right? Mole fraction of benzene in the gas form in container number 2 is 0.714. That's what's given in the question. So it's really irrelevant what happens here in container number 3. So I'm just going to bypass that and just focus on container 2 and container 1, because that's really how we can go ahead and solve the problem. Now, we know that that mole fraction of gas is 0.714. From Chem 11, as I mentioned in the Zoom earlier, we remember this relationship of partial pressure to total pressure, which is the one given here. So if I want mole fraction of a gas, I can calculate it by taking its partial pressure divided by its total pressure. In other words, if you will, taking the pressure of the gas here, just the benzene, and then dividing it by the total pressure that's generated by the benzene and the toluene gas. Okay? Now, so let me write it up here separately so you can see it better. So if I want the mole fraction of benzene gas in any mixture of the gases, I would take the partial pressure of the benzene gas divided by the partial pressure of the benzene gas plus the partial pressure of the toluene gas. Since in this case I happen to be talking about container number 2, that's why all of these numbers have 2 next to them, okay? Right? They all have 2 next to them. Now, I know that the partial pressure of benzene, which is the gas, benzene gas, I can calculate using Raoult's law, right? So remember, Raoult's law is just partial pressure of something, right? Like vapor is going to be the mole fraction of the liquid times the pure vapor pressure of that liquid. Okay, that's just Raoult's law, right? So if I want to calculate the partial pressure of benzene in container number 2, what I need is going to be the mole fraction of benzene liquid in container number 2 times the pure vapor pressure of benzene, which is 750. And that's what I have there in the numerator. The denominator is the vapor pressure of the solution number 2, which is the sum of the partial pressures of both the benzene and the toluene, and they're both calculated using Raoult's law. So this is the mole fraction, this is this expression right here is the same exactly as the numerator, right? And then the other one should be the toluene mole fraction in the liquid in container number 2 times the vapor pressure of pure toluene, which is 300. All of that whole expression right there is equal to 0.714. That's what we were told at the beginning. Okay, so don't forget that that's the information that we were given. All right. The other thing, of course, that I can do here is I know that since there's only 2 components, the mole fraction of toluene should be 1 minus the mole fraction of benzene in that same phase. In this case, we're talking about the liquid in container number 2, so that's why there's 2 there, okay, for both of them. The reason that is useful is because then I can substitute this expression into the denominator, one of the denominator expressions right there. So you see how I change it here. Instead of writing mole fraction of toluene liquid in container number 2, I change it to 1 minus mole fraction of benzene liquid in container number 2 times 300. Once I get in that form, then I can distribute my terms in the parentheses out. You can see that one of them is going to be 300 times 1, and the other one is 300 times minus this expression. Now, 1 times 300 is just 300. That's where that thing is. But then the other one is 300 times minus this, which gives me minus 300 of the mole fraction of benzene liquid. But I already have 750 mole fraction of benzene liquid. So if I just combine those two terms together, 750 minus 300 is 450. So that's why I get 450 mole fraction of benzene. So this is just all in the denominator part, okay? Once I have that, I'll cross multiply, right? That will give me 750 on the left side, which is just the numerator portion of that, is staying on the left side. And then on the right side, once I cross multiply, I get these numbers right here. I get this expression. Okay, 0.714 multiplied by each of these things. Excuse me. Once I do that, I can combine the same expression. These both have the mole fraction of benzene liquid. I'm going to combine those two things together. 1 minus the other one gives me this, 428.7 mole fraction of benzene liquid in 2 equals to 214.2. That allows me to solve for the mole fraction of benzene liquid in 2, which is just 0.49965. Okay, so notice that's the, just going back to the picture here, that's the proportion of benzene liquid in here, in container 2, okay? You see what I'm circling right now. But that liquid comes from the gas in container 1. So in other words, that's the same as the mole fraction of benzene gas in container number 1. This is one thing that I went through in some detail earlier in the Zoom session. So if you're sort of not understanding this clearly, you might want to watch that part of the Zoom session earlier on why the gas in 1 is the same proportion as the liquid in 2. Okay, because the gas and the liquid are basically the same thing. They're just being changed into different states here. Okay, all right. So that's what I wrote here. I said that the mole fraction of benzene liquid in 2 is the same as the mole fraction of benzene gas in 1. And both of them are equal to this number, 0.49965. Now, I'm basically repeating this entire step that I did here, but with container number 1 now. Earlier I was working it on container number 2, now I'm doing it on container number 1. So I can say that the mole fraction of benzene gas in container number 1 is the same as partial pressure of benzene in 1 divided by the total, which is the vapor pressure of the solution. Now, the partial pressure of benzene in 1 comes from the mole fraction of benzene liquid in 1 times 750, which is the pure vapor pressure, divided by the total. The total is the sum of the two partial pressures, right? The partial pressure of benzene in 1 plus the partial pressure of toluene in 1. And the partial pressure of each one of them can be calculated using Raoult's law. Okay? That whole thing should equal 0.49965. And so I'm just repeating my steps as I said earlier. Now I substitute, instead of mole fraction of toluene, I write it as 1 minus mole fraction of benzene liquid in 1. And then I expanded that expression. Again, I get 300 times 1, which is 300, and then 300 times mole fraction of benzene. That's the negative 300. 750 minus 300, again, is 450, right? So then I have this new expression now. All I need to do at this point is cross multiply. When I do that, I get 750 mole fraction of benzene liquid in 1, and that should equal to, the other side is the cross multiplication. You get 224.8 mole fraction of benzene liquid 1, and then 149.895. I'm going to combine same terms here, which is the terms that contain mole fraction of benzene liquid 1. That gives me 525.16 times mole fraction of benzene liquid 1. That whole thing equals 149.895. If I solve for mole fraction of benzene liquid in 1, that's 0.286. And that is what the question is asking. If you want the mole fraction of toluene liquid in 1, then all you need to do is take 1 minus 0.286, right? And then you get 0.714, okay? So that's how you solve that problem. Again, I apologized earlier in the Zoom session. I think the variables get a little confusing, and I want to make sure, I just didn't want to like solve it there and then get the wrong number, since there's a lot of different variables. So I think this gives a bit more organized solution to question number 8 on the practice. Okay.